Very nice. So welcome everyone. I'm very happy to welcome you to the very first undergrad seminar. Before we start, I would like to give you an overview of what this really is. Today we'll have three speakers. They're all first-year students, just like you probably, or younger. And they're very excited to present what they have here. So that's basically what we're doing. So, of course, if you haven't scanned this, you should scan this. I want to talk about very briefly about the idea and the motivation. So it's not something that's absolutely new. I do not claim this to be some revolutionary idea in a sense. It's part of the old math. And so as you might know, Serge Bell came and then he changed all the programs. He put 3 more letters, I think, to every single meter. I'm not sure who's counting. And in the new program, it was more data analytics based in some sense. And so some of the math stuff got canceled out, and that wasn't so good. So this was originally a course. The course structure was you pick a topic, you make a presentation, and you write some sort of article or paper on it. And we would like to reproduce this here. How do you choose a topic? There's this question. If you come to us and you would like to register, how do you choose a topic? Well, it's very simple. We sit down, we have a meeting, and we try to find something that's suitable for you. So, for example, Noah is a physicist. I don't think he would be interested in doing some weird, nonsensical, algebraic, topological Lie group theory. So, some sense, I made this up. I don't think there's such a thing. But we could look at something of your interest and take a look at it. Like, for example, I was talking to Farouk, and he told me he wants to do something related to Lagrangian mechanics. That's because it's his interest. It doesn't matter if you're a physics major. Today we have Ahmed, who's a computer science major. He came to me, he told me he wanted to do something related to computer science. And so he's going to give a very interesting talk about quantum algorithms. So this is just an example, just a small flavor of what we would like to do. Usually the first step. So pick a topic, and then how do you move on? So if you've chosen a topic, let's say it's the Lagrangian mechanics stuff, which I do not claim to understand, so I won't be making more meaningful examples from now on. You choose a topic, and you would like to get going. What's an action plan for this? And it's very simple. You're given a very specific set of goals, or maybe just one specific goal. So, for example, for the presenters who are presenting today, they had this very specific goal of proving theorem 2.22 in this paper article, or exploring a specific proof. So you would comment on the techniques that's being used there. So, or you would demystify something that's very weird and you don't know how it works. So you're always given a very specific goal. It's not like you're just left there, oh, prepare a topic, prepare a talk, do everything on your own. We're here to help you out. And then, well, the next step, I don't think we'll need the next step. I think, well, maybe I skipped over too quickly. So the next step is after you prepare something and you do your research, you ask the questions, you meet out. We actually meet every Saturday and discuss this very interesting mathematics that you won't really find within the scope of any classroom. And we make progress. We study things that are well studied, but it's fine. You know, there's something called a quantum Fourier transform. This is completely fine, but at the same time, you can still spend time on it, try to learn it, see what the ideas are, see what the techniques are, and you gain something from this. Not only that, the key difference between what we're doing here and what was done in the original program for the mathematics major is that the course was actually mandatory. But here, you have the choice. I think that's what makes all the difference. You have the choice, you're coming to us, you want to learn about something, you're motivated to discuss it, to explore what is really behind this very specific construction that you've picked, or this very specific idea that you would like to find out more about. And because of that, and perhaps this is a subjective opinion of mine, I think it is much, much better than what we standardly had in the classroom. We're now outside of the classroom. Today, I will prove this. Well, not me. Well, we will prove this. And we have three very prepared, very motivated speakers who will show you exactly why this is true. So that's it, honestly. Thank you very much. I want to know if anyone has questions. And by the way, you can sign up here. So that's very important as well. Yes.
Is this the first time that this event is carried out after the course was taken away?
Yes, exactly. Exactly. And we plan to have it on a bi-weekly basis, hopefully, if we have enough participants and enough people to join us. I think this is something we can achieve. I've got lots of people who texted me. They were like, I want to do this. I want to do this. And it was very interesting to see, because at the time, I'll even tell you an interesting story. Like at this class, at this undergrad seminar, we had another math class right before it. And once the class was over, we had like 15 people in a math classroom. This is also something that's very interesting. 15 people in a math classroom. But then the moment the class is done, everybody leaves. And it's only the speaker and two other speakers who have to present, and the professor. And that wasn't really what I think the goal of the course was. But here we have everyone. That's something I'm very pleased to see. So. Well, if we don't have any more questions, then we'll start with the first talk in 5 minutes. Klesta Shehaya is giving a talk on random walks in Z to the D. Thank you.